Okay, so in this particular case, we've been presented with this equation and we've been asked to balance it and to use only whole numbers, in our final answer, basically, right? And what do we have here? So we've got it's effectively, beryllium hydroxide reacts with an acid to produce more or less a salt plus water. One of the things you may or may not know about beryllium hydroxide is that it's amphoteric, right? So amphoteric. I'm just going to leave this here because it's not necessarily central to what we're about to do at all in this particular question, as far as balancing the equation. But in your own time, you may want to look this up to find out what it means. It's got to do with its beryllium's ability to act both as a in this particular equation, it's acting as a base, but it has the ability to work to function also as an acid, right? So if you go and look into how it might react with something like NaOH, you might find something interesting. So, but anyway, that's not the focus of this. We're going to focus on just the balancing aspect of this whole question. Okay, so the first thing I'm going to do is I'm going to work on auditing this equation. I'm going to look at, well, what's the frequency with which elements occur on either side of the equation. Okay, so let's go through that process, right? So we're going to look at the left hand side, right, LHS, and we're going to look at the right hand side, RHS. Okay, now in looking at the left hand side of the equation, you've got hydrogen, nitrogen, we've got oxygen, we've got beryllium, right? So HN Be here and oxygen. Okay, okay, so let's go through this process. Let's count the occurrence. Let's start with the hydrogen. So we've got one H here and we've got OH2, so we've got 2 here. So we can say that would be a 3, right? So 1 plus 2 would be the 3. In terms of the nitrogen, it only occurs once in the NO3, so we can say that's just going to be a 1, right? And BeOH2, so that occurs only once, right? And oxygen, so we've got O3 and we also have OH2, so 1 times 3 plus 1 times 2, right? So that's basically 3 plus 2, so we've got 5 for oxygen. If we bring our attention now to the right hand side, so the product side of the equation, for hydrogen we've got H2O, and it doesn't occur in the other species, so that's usually going to just be 2. Nitrogen occurs here, so we've got NO3 2, so N would be 1 times 2, right? So that occurs twice. Be, it's just Be, right? And then it's got this, so it's just going to be 1. And for oxygen occurs in both species, so it occurs here. We've got O3 times 2, and we've got O, so it's going to be 3 times 2, which is 6. And then 6 is going to need to be added to this 1, so that gives us 7. Okay, right, so this is effectively what we've got, and you can see that the hydrogens are not balanced, the nitrogens are not balanced, the berylliums happen to be balanced, and the oxygens are not balanced, right? So what can we actually do at this stage? Well, one of the first things I'm going to choose to take my attention towards is nitrogen occurs in 2 species. It occurs in one species on the left hand side, it occurs in one species on the right hand side. Okay, so if we want to get a balance for that, if we multiply HNO₃, which is the left hand side species, if we multiply it by 2, we're going to have 2 nitrogen here and 2 here, right? So we've got 2 already, so that's going to effectively create some level of balance between the nitrogen. So that's the first step I'm going to take. And so let's take a look at what the new equation is going to look like, right? So we're going to have 2 HNO₃ plus BeOH2, and that produces BeNO₃ 2 plus H2O, right? So let's audit this again. Let's figure out what's our new what's the new figures that we've got after having done that. Now, we didn't change anything on the right hand side in terms of any coefficients or anything, so for the right hand side it's going to be exactly the same as what it was here, right? So we're going to have H and BeO, right? Going to have 2, 2, 1, 7, right? And on the left hand side, we've changed some things, but other things we haven't changed, right? So we've changed this species, we haven't changed this. However, OH, we've got OH occurring, oxygen, hydrogen occurs in both species. So, but what doesn't occur in the species we've changed is beryllium. Okay, so H and BeO, we can kind of infer straight away that, okay, well, for beryllium it's going to be the same, right? But for the others, there is a shift. So for the hydrogens, I've put a 2 here, so that 2, the impact on the hydrogens would be, we've got now 2 plus 2, right? So for the hydrogens, the new value is going to be 4, okay? And for the nitrogen, which was the main focus at this stage, that's going to be increased from 1 to 2, right? So it was 1 before, it's now 2. And for oxygen, we've got, now we need to do 3 times 2, which is 6 plus 2, right? So that's going to give us 8, okay? And if we look at what we've got now, we can see that the nitrogens are now balanced, and the hydrogens are not balanced, and neither are the oxygens. Looking at the equation on as far as which has less of these different elements, you can see that on the right hand side, which is where there's less hydrogens and less oxygens, we've got the H2O, right? Which is the species in which, at least on that side, is the only species where we've got both hydrogen and oxygen, right? And so if we modify that, we will be modifying both the hydrogen and oxygen. So consider we need to double the number of hydrogens present on the right hand side, and the number of oxygens, we do need to increase that by 1 if we want to make it balanced. So what effect would placing a 2 in front of the H2O have? If you place a 2, it's going to double the number of hydrogens, and it's going to increase the number of oxygens by 1. So that's what we're going to do. So if we do that now, 2 HNO₃ plus BeOH2 produces BeNO₃ 2 plus, and then we put our 2 there, so 2 H2O, right? Now, because we've not changed anything on the left hand side, that stays the same, right? So we're going to have for left hand side that's going to be H. Gonna have 4 and 2 Be, 1 oxygen, 8. Okay, and on the right hand side we're gonna have well, on this side we need to be mindful of what we've changed. So we've changed the H2O aspect of the right hand side. So if I just put this together, so we've put a 2 in front of our H2O, which means that we're going to be 2 times 2 for the hydrogen is going to be 4, right? For nitrogen, we didn't change anything, so it's going to be the same as before. So it's just N times 2, which is going to be 2, right? For beryllium, we didn't change anything. It's just going to be Be times, well, not times any, times, it's just 1 basically, right? So, and for oxygen, if we look at that, it's going to be 3 times 2, 6, plus 2 times 1, which is going to be 6 plus 2, which is going to be 8, right? And if we now compare the left hand side and the right hand side, what do we see? Well, we see that we've got actually, now H is balanced, N is balanced, Be is balanced, oxygen is also balanced. So, so yeah, I mean, we've got a balanced equation now. And we've also adhered to the requirement of only using whole numbers, right? So we can put, we can say that in the balance equation, we're going to have effectively a 2 here and a 2 there. So in this case, this is our balanced equation, right? Right.